Welcome to the AI and GIS Frontier podcast. Let's get into today's topic.
Today, we are covering AI for disaster response and prediction. This is growing at 15.6% annually as a research field, and the real-world impact is already saving lives.
What can AI actually do for disaster management right now?
The headline numbers are impressive. AI-based flood mapping has hit 92% accuracy, wildfire modeling is at 89%, and tropical cyclone tracking errors have been significantly reduced. But accuracy is only part of the story. The speed is what really matters in disaster response. AI-driven systems can analyze satellite imagery of a disaster zone and produce damage assessments within hours of image acquisition. During a wildfire, that means fire managers get updated. Burn perimeter maps almost in real time, rather than waiting for manual interpretation that could take days.
How does this affect forestry operations?
Wildfires are the obvious connection. Forest agencies are using AI models that combine satellite-derived vegetation moisture indices, weather forecasts, fuel-type maps, and terrain data to produce daily fire risk assessments. In Canada and the Western United States, fire management branches use these systems to position suppression resources before fires start. Post-fire, deep learning models automatically map burn severity from satellite imagery, classifying areas as unburned, low severity, moderate severity, or high severity. That burn severity map drives reforestation planning, erosion control priorities, and salvage logging decisions. Getting it within days instead of weeks means faster response and less environmental damage from post-fire erosion.
What about other natural disasters that affect forests and the environment?
Landslide detection from satellite imagery is advancing rapidly. In mountainous terrain with logging roads and cut blocks, landslides are a major risk and a significant source of sediment delivery to streams. AI models trained on satellite and LiDAR data can identify landslide-prone terrain, detect new slides quickly, and track recovery over time. For flood management, AI is improving flood extent prediction and real-time monitoring. Forest watershed managers can use AI-enhanced flood models to predict which stream crossings and roads are at risk during rain events, enabling proactive closures and reducing infrastructure damage.
I have read about AI being combined with augmented reality for disaster response.
That is an emerging area. The idea is that a field responder wears augmented reality glasses that overlay AI-analyzed geospatial data on their real-world view. During a wildfire, a crew leader could see the predicted fire spread overlaid on the landscape, with highlighted evacuation routes and identified safety zones. For search and rescue in forested terrain after a natural disaster, the AR display could show AI-predicted areas of high probability for finding survivors based on population data, terrain analysis, and damage patterns. It is still experimental, but the combination of real-time AI analysis with spatial visualization in the field is powerful.
What about the GIS workflow for disaster response professionals?
The workflow is shifting from reactive to predictive. Traditional emergency GIS meant waiting for a disaster to happen, then rushing to produce maps. AI enables a preparedness model where you have pre-computed risk assessments that update continuously. When a disaster does strike, the AI immediately starts processing incoming satellite imagery, matching it against pre-event baselines, and generating damage assessments. The GIS professional's role evolves from heads-down digitizing under time pressure to configuring and validating AI outputs, managing data flows, and ensuring decision-makers get accurate information quickly. It is a more strategic role.
What should GIS professionals in emergency management focus on?
Learn to work with rapid satellite imagery providers like Planet and Maxar's Open Data program that release imagery during disasters. Get comfortable with change detection workflows because disaster assessment is fundamentally about comparing before and after conditions. Understand how AI models for flood mapping, fire perimeter extraction, and damage assessment work well enough to validate their outputs. And practice producing decision-ready products under time pressure, because that is the reality of disaster GIS. The AI handles the analytical heavy lifting, but a human needs to quality check the output and communicate it effectively to incident commanders who are making life safety decisions.
Clear and actionable. AI is clearly making disaster response faster and more accurate, and GIS is at the center of it.
It absolutely is. And the research growth rate of over 15% annually means the capabilities are only going to accelerate. GIS professionals who build skills in this area are going to be in high demand.